well. Here I'm just going to talk about several different terms that have been out there that people have been talking about. So multi-lane roundabouts. Multi-lane roundabouts are multiple lanes into and through the roundabout. This is a much more challenging situation for bikes and pedestrians. There's multiple lane crossings that people have to cross and so on. This is really only preferred in situations where we are on an arterial, we've got high traffic volumes and so on. Turbo roundabouts, another term that you may have heard. And this is an alternative to a multi-lane roundabout, but this incorporates spiraling lanes. And what happens here is you actually have to select the lane that you want to use before you enter the roundabout, based on where you want to exit. Once you get into the roundabout, by use of curbs or some other thing to discourage the ability to change lanes while in the roundabout, you just follow the path that you're on and you will eventually end up at the exit or where you would leave the roundabout. So it restricts the lane changing when you're in it. This is primarily done to increase efficiency for vehicles. The Dutch Bicycle Priority Roundabout, or the Dutch Roundabout. What you're looking at here is that red circle around the outside. This is that separated circular bikeway. And the primary consideration here is that bikes and pedestrians have the right of way. So vehicles must yield to any bikes and pedestrians within that bikeway. They've installed these throughout Europe in multiple different locations. And some of the data that they're seeing back at this point is that there's actually an increase in crashes related to this compared to a more conventional roundabout design. Traffic circles. These aren't roundabouts, they're larger than roundabouts. This is one that's located in New York City. It's one of the most famous traffic circles of all time. This can have actual stop signs or traffic signals within that circle. And it's relatively large and it has relatively high speeds. Protected intersections. This is a word we've all heard recently. This is a signalized intersection that offers separated and protected facilities for bikes and pedestrians. And it allows the ability to give priority crossings for bikes and pedestrians. So we can allow bikes and pedestrians to actually complete or start their movements prior to vehicles being able to move forward. And it's an improvement on the traditional signalized intersection. Unfortunately, it doesn't offer any meaningful improvements to safety as it relates to car versus car crashes. It's still the cross intersection, still subject to those type of T-bone or cross 90-degree crashes. Then we have a short video talking about protected intersections. This is from San Luis Obispo.
Similar to a traditional intersection, except that it provides more separation and visibility between the different modes of travel. Since being in a car, on a bike, on foot, or in a wheelchair, each have their own unique needs. This is achieved by what are called corner islands. Corner islands help slow down automobile traffic at right turns, where it is particularly critical for safety. Corner islands also make those who are on a bike or on foot more visible and decrease the distance for those walking or using a wheelchair to cross the intersection. For drivers, a protected intersection is very similar to a typical intersection. Look for people on bikes in the bike lane on your right-hand side, and expect to see bikes stop further up where they can be better seen by drivers. When making a right turn, avoid the corner island curbs, including mountable truck aprons that help larger vehicles navigate a wider turn radius. Another thing to remember is to look out for pedestrians. Be sure to yield to them in the crosswalk as you would at a typical intersection. Some people on bikes don't feel safe merging into traffic to make a left turn. A protected intersection is designed to make that a little bit easier. You can make a left turn by using the perimeter of the intersection, riding in a counterclockwise fashion, unless markings indicate otherwise. As you approach the intersection, stay in the bike lane until you reach the corner island. When the light is green and it is safe to cross, ride in the bike lane to the corner island on the other side of the intersection. Then turn your bike left and wait at the limit line, requesting a green light in the new direction. When the light is green and it is safe, proceed in the bike lane through the intersection in the new direction. Be safe out there and look for more protected intersections to come.
And finally, that brings us to modern roundabout, which is the roundabout that we're currently talking about with this project. It offers yield control at all entry points, so anyone entering the roundabout has to yield to drivers already in the roundabout. It could be circular or non-circular, although circular is more common. And it relies on vehicle deflection, so basically geometry that will change how people drive to slow people down, to improve sight lines so that you can see other vehicles and you can see pedestrians. Pedestrians only have to cross one direction and one lane at a time. And then finally, as I mentioned, that vehicle deflection allows for much lower speeds. So typically speeds are 15 to 20 miles an hour driving through a roundabout designed appropriately. Then we have another video from San Luis Obispo on roundabouts.
Hi, I'm Luke Schwartz with the City of SLO Public Works Department, and I'm here to tell you a little bit more about roundabouts. You may not know this, but roundabouts are the city's preferred form of intersection control. They help traffic flow more efficiently with fewer stops and less greenhouse gas emissions compared to a traffic signal or an all-way stop. They're also great for pedestrian and bicyclist safety in that they slow speeds and reduce conflict points at crossings. And equally important, they reduce the potential for really severe collisions that can lead to injuries or fatalities on our streets. Roundabouts are just one way that our transportation department is supporting our city's climate action goals and Vision Zero policies through smarter transportation planning. To learn more, click on the link below this post. Hi, I'm Luke Schwartz.
Okay, apparently we needed to see it twice. Again, a modern roundabout should be considered anywhere that there's a traffic signal or stop control. So this really, many communities, including San Luis Obispo, are moving towards this roundabouts first policy, where a roundabout would be a preferred alternative or a preferred option for every intersection, at least as a first resort, and then we would move down the list. For schools, its primary function is to reduce those vehicle speeds, and that is critical when it comes to safety. We could reduce conflicts, but we cannot eliminate them. So we also have to reduce speeds because that's the critical factor in any sort of crash that we have, whether it be vehicle. Within corridors, this really is an opportunity to shape these cross sections. We can beautify those center islands. And for this particular project, we do have beautification that we've been coordinating with, and there is plans to come in after the construction is complete to beautify the roundabout, the center island. There's an opportunity along the retaining wall, along the MEMS frontage, to beautify this and make this a true gem for our city. And of course, this is used in intersections with existing high crash severity and frequency patterns, and that's what ultimately qualified this project for this grant. I won't bore you with all of this stuff again, but there's some pretty significant safety benefits by way of reduced crashes, both for total crashes, vehicle crashes, pedestrians, and so on, for all modes of traffic. And the way this is accomplished is through multiple things. As we mentioned, one of them is speed. One of them is just reducing those conflicts. So in a typical signalized intersection, we have 16 to 24 conflicts, as you're seeing on the left side. And this is pedestrian to vehicle conflicts, I should clarify. So we typically, on a typical situation, would have 24 to 16 in a typical signalized intersection. A roundabout boils that down to only 8 conflict points. Similarly with vehicles, those conflict points are the same in the sense that we can go from as many as 32 that you're seeing there on the left side down to 8 with the roundabout. To remind everyone, this is the